Alright, so hello and welcome. Here we are again with another question of the volume way up because I'm just going to whisper. Number of digit 1, LeetCode hard. Alright, let's get right into it. So I don't know what I'm doing anymore. I'm just gonna try, oh no, wait, go back. Didn't mean to do that. I'm just gonna go ahead and try to, just gonna keep going. I looked at some other problems earlier and it was some solutions I was looking at and it's like, oh man, I don't even remember how to do that. Alright, so count digit 1. Count the total number of digits 1 appearing in all non-negative integers less than or equal to 1. Oh, okay, I was gonna say in one number? It's not particularly hard. All non-negative integers less than or equal to n. Oh, in a billion? Okay. Oh, that's interesting. Number of digits 1 appearing in all these integers less than or equal to n. Huh. This is just like a math question. Also, I've got the headset charging here. Alright, yeah, this is probably kind of an easy one. So the number 1 is 1. Then in the, you could say, number 1 has 1. Well, you could maybe do this in logarithmic time instead of constant time. It might be easier. So the number of times you see 1 in 0 through 9, then you can, that's once, right? And that happens 10 times when you're moving from 0 through 9 to 10 to 100, right? But also you have 1 added, at one point you would add, so you could say 0 through 9 is once, then 10 through 99, you have 0 through 9 10 times, or is it 10 times? Yes, 10 times. Excuse me, so multiply by 10, so you have 1 plus 1 times 10, and you also have another 1 10 times as well, because you have 10 through 19, right? So there's 10 of those where you have a 1 there as well. So 10 through 99, you have 10 ones in the 1's digit and then 10 ones in the 2's digit. Excuse me. That gives you 20. That's 21 from 1 to 200, or 1 to 199, from 0 to 99. Then from 100 to 999, you have the same number of ones from 0 to 99, again 10 times, and then also 100 times you see a 1 in front. So 0 to 99 we said is 20, and then from so you have 200 from 0 to 99 10 times, and then also you have 100 times you see another 1, so you have 300, right? 200 plus 300 plus another 100 is 300. So it looks like you have 1, 20, 300, probably the next one is 4,000, or no, not 4,000, you have 300. The next iteration you're going to say there are, that 300 times is going to happen from 1,000 to 9,999. 10 times you have 300, so you get 3,000. And then 1,000 times you also get another 1, so you have 4,000. So you have from 0 to 9 is once, from 10 to 99 is 20 times, from 100 to 999 is 300, from 1,000 to 9,999 is 4,000, and then so on. Basically, you just increment your number and multiply by 10 for each section that you're gonna loop through. You're gonna walk through. Now, what's tricky about that is you could say, so that gives us, so the digit that you're looking at, you could multiply by 10 and just increment for each digit. So once you get to 1 billion, you multiply by 10 9 times, I believe. So we said 10 to 99, so 2 digits. That gave us multiply by 10 once. So 10 digits multiplied by 9 times. Is that right? Yeah, sort of. Like 1,000 to 999 is 3 digits. Excuse me, 4 digits. 9,999 is 4 digits. That we said is 4,000, right? So 4 digits gives you 3 zeros, 10 to the third. So take the number of digits and subtract 1. That's how many times you multiply by 10. So 10 to the 9th is 10 digits. So you multiply by 10 to the 9th. Is that right? That doesn't seem right. I think if you multiply by 10 to the 8th. So 9,999 is 1 less than, oh that's right, oh that's why, because 1 billion was, there's 1 less than that, is how many digits. That would be actually 9 digits rather than 10, and so you have 10 to the 8th, right? Is it less than 10 to the 9th? Is it equal to 10 to the 9th? Yeah, so you have 10 to the 8th, and what do we have? We had 10 to the 0th, we had 1, 10 to the 1st, we had 2, 10 squared, we had 3, so 10 to the 8th was 9 times 10 to the 8th. That's how many for 1 billion. 9 times 10 to the 8th plus 1 for 1 billion. Okay, so now the tricky thing is, that would be, that could give us, each section, but we kind of want all the numbers up to that point. Now, does that work if we do? So yeah, this is not too hard, but a little harder than I was expecting. We're 8 minutes in now. So tricky thing though. Yes, we can get all the numbers up to, like for instance, we had, let's say we had 8,000, right? 8,196, right? We can get all the numbers up to 8,000, but we run into some issues because first off, like, yeah, we can't really go digit by digit. I would like to go left to right from digit by digit and calculate it that way, but that's kind of challenging. We can definitely get up to 8,196. We can get up to 1,000, right? All 0 to 99 is just, we can get that sum. But then we've got to go from 1,000 to not 9,999, but 1,000 to 8,196. And we can't just loop through. We've got to do something that's a little more efficient than that. Well, each subsection of 8 says 8 times we have these thousands, right? So you could consider it with a 0 in front for the first 1,000. So 0 to well, no, it's a little bit different when you have a digit in front. Well, no, not entirely. It's pretty much the same. Yeah, from the first 0 to 999, you have, we would say you have 321, and so you should have 321 for each of those sections, except the one where there's ones in front. So where there's ones in front, you would add a 1 for every number, so there's 1,000. 0 to 99 would give you, or 0 to 999 would give you 1,000 ones in addition to the 321. Yeah, 0 to 9 is 1, 10 to 99 is 20, 100 to 999 is 300, so you have 321 to go from 0 to 999, or 0 to 999 is 321. So each 1,000 is 321. So then we could say for 8,000, you can say you have 321 times 8 plus 1,000 for that one time you pass through 1,000. So for each digit, you can do it that way. You can have a sum from 0 to 9 of each section, each digit section, how many ones you should see, and then add all the ones that you'll see. That's if the digit is less than 1 that you're looking at. If the digit is larger than 1, so it's less than 1, you don't add. If it is larger than 1, you do add the section where you have ones. But one issue there is if you have, so we said 8,196, but now once you're past 8,000, now you have the same number of ones as 196. Now here's the tricky part. If you had a 1 in front, then you would take the same sum that you're going to get, but also add whatever that number is again, whatever's left over, you would add that, because all of those would be ones in front, all of those numbers, in addition to the other ones that you'll see. But you could do the same, so if you had 8, you'd have 0 to 999, which is 321, so 1,000, we'll say. Multiply that by 8, multiply that by 8, and then also add 1,000 for when it's a 1 there. And that's how you process 8. And then you do the same thing for the 1 that follows. At 196, so you would do 100, 0 to 99. 100 is 100, 0 to 99 would give you 21. And then the 100, you'd say you have a 100 in front of all those numbers from 100 to 96. Or from 100 to 196, so you would add all of those numbers again with a 1. I'm not sure if that's entirely correct to do it that way. Well, certainly, yeah, you have 21 for the first 0 to 1. So I think actually subtract 1. So you would say for 8, you would do 321 takes you from 0 to 7. And then there's no 1 when you get to 8. Yeah, so it works fine. You multiply by 8, that's fine. Then also the 1 for, there's 1,000 times, there's a 1 in front of everything. You just have to add that 1,000. And then also for the 1 to 196, for 196. So that 8,000 in front doesn't really matter. You can just consider 1, and so again you have 2 digits there, right? 0 to 1 is 1, so 1 times 321. And then now the next number is 196. All of those have 1s in front. Now the question is, do you add everything to the right, or do you add everything including the 1? I think it's just everything to the right. So it would just be 96. I don't think it's 196 because you only have 96 of those numbers have a 1. So you would truncate by, yeah, you would shift to the right 1 digit and add whatever's left there. Question there is, how do we could generate each of those numbers too. As we generate our digits, we could generate the sum up to that point as well. So we can I'm wondering a more efficient way to process this. So we definitely want to go digit by digit. We go left to right. You could convert the integer to a string and then get the digits that way. I think that's a simple way from left to right. Place them into an array. I guess you start at the back of the array, and then you can also process the array to get at each of those indices also what the current number is. Yeah, I think that's a simple way to do that. And then save the digits and I guess it'd be the prefix values, and then that way you can, when you see a 1, so 196, you can process 1 times the 1 times whatever that, also calculate for each of those values for whatever index position you're in, right? So if you're 1 digit, or be really the 0th position, you would have 1, first position you have 20, second position you have, or it really should be 21, it should be the sum, so 21, then 321, then 4321, right? Calculate all those, there's 9 of those numbers. It's just there's a power of 10 that keeps incrementing from 10 to the 0, and then an integer, a value that keeps incrementing, and you just add that value to the previous value. So you can calculate all of those as well. And then you can say, right, so when you see something that's not a 1, if it's greater than 1, you would multiply by that other value that I just mentioned we calculated. And maybe it would be better to actually use the digits directly in the array. So, so 1 digit would give you 1, 2 digits would give you 21, 3 digits, 321, etc. And then so if you see 1, you would, or you see 2 rather, 2 is greater than 1, so you'd have 2 times and the number of digits that were at that position, which, or at least we're looking at like 8196, right? So the 4th digit is 8. So 4 digits, and so we can use that index. We can get the digit number. We just add 1 to whatever index we're working with. So that would be 4, which give you 4,321. Multiply that by 8. Add that together to our total. And then when we also have to add another factor of 1,000. You can just take whatever that digit is, 4 digits, and just take 10 to the 4th, and add that, or excuse me, 10 to the 4th minus 1. So I guess whatever index we have, 10 raised to that index. Add that. If we're less than 1, we don't add that at all. If we're equal to 1, then that's where things get interesting, right? That's when you do the same procedure, but now you're going to add that prefix value that we calculated, where you have 1 less digit. So subtract 1 in your index, if it exists, right? If you're not at the last index already, and then you add that as well for all the 1s, and so that's how you process each digit. Kind of involved, kind of complicated, but that works. That'll do the trick. Some pre-processing steps we have to do, but overall it's logarithmic time in terms of the number of digits, log base 10. So yeah, so we're gonna we're gonna convert to a string to get the digits. excuse me. I think it's, actually I already know. It's, excuse me, there's, it's going to be standard 2-string. I think works. I was thinking about S to I and I to S. I don't know if you can do I to S. I don't know if that exists. Iota, yeah, 2-string is the one. So we can go 2-string, and we can have an array. Oops. Const int digits is going to be s.size. We can say int, not x, but we'll say v array dp. What do I use different? So we can say d of digits. Yep, and so we're going to say for int I equals 0, I is less than number of digits plus I. We can say we said we want to go from the back, right? So what's interesting is that the most significant digit is on the left, and that's actually going to go on the right side. So d of is equal to s of I minus 0 is the value, and we're going to say d, and this really could be, this doesn't need to be an int, this could be just something that has like, really could just be 2 bytes, but int is fine. It works out okay. We could do like a short or something. And then we can say if this is actually on the other side, is the most significant bit. So this is going to be digits of I minus I minus 1. Yeah, on the other side. So that's kind of interesting. So we're going to retrieve digits. To an array with the most significant digit in the last index of the array. Okay. And now we're going to say preprocess to generate some values. First, have values, an array of values for these sums for a given range digits. For 0 to 9, have 1. For 10 to 99, we have 20. 21. 0 to 999, 321, etc. So int I equals 0, and we're going to have, actually I is going to be the number of digits. How are we doing on time? 23 minutes. Okay, this is probably takes another 20 minutes or at least. So int, so we're going to call this like, I don't know what to call it. It's not a prefix, but it's going to be a sum total, subtotal, like you could call them subtotals of, we're going to say digits plus 1, because it's actually going to start off at 1. And we're going to say I is 1. And we could do it this way, equals 0. So these 0 digits is going to be 0. We're going to have int pow equals 1. And we're going to say digits, I is less than digits plus 1, or less than or equal to digits Might be easier to say just less than digits plus 1. And we're going to say subtotal is going to be equal to of I is going to be equal to subtotal of I minus 1. So you multiply that by 10, you add 1 to it, add 1, multiply it by 10. It might be easier actually just to say subtotal of 1 equals 1. Add 1 to that value. No, it's not actually. That's not the way to do it. This is fine. We're going to say it's just I plus 1 times 10. So when I is 1, so 1 digit, it's actually I times 10. Oh, no. Yeah, I plus 1, but if when we're looking at 2, it's just I, 20, plus the previous subtotal, I minus 1. So when I is 1, so when I is 2, it's 20 plus 1. And really this is just start off at 2, I think. Yeah, this is a little bit easier to do it this way. And it's not 10, no, it's not 10, no, I'm sorry. It's fine to do it this way. It's not 10, but it's pow times I, and then pow actually updates to pow times equals 10 each time. It's a little confusing how this works, but there's a power of 10 times I, so when I is 1, you do 1 plus subtotal of I minus 1, which is 0. 1 plus 0 is 1. Subtotal of 1 is 1. When you get to 2, you get your power is 10. 2 times 10 is 20, right? And the previous subtotal is 1, you get 21. Then you get 3 times 10 is 300, plus 21 gives you 321, then you get 4, 3, 2, 1, etc. So these are all the subtotals that you get for the number of digits. And second, let's have an array of prefix sums values for truncated versions of our integer. So this is kind of interesting. We're going to go, so int current we'll say is 0. We're going to say for int I equals 0, I is less than d, or digits, plus I. We're going to say const int val is going to be d of I. And we're going to say current is going to be 10 times current plus this value. And we're going to say, so int prefix is going to be, so what's interesting here is that, so the digits, the smallest digit should be the least significant digit. That's what we want to do. So this works kind of nicely. So we can say prefix of I, and we're going to say, starting from the 0th position from the right, going left. Yeah, that's fine, including prefix. This prefix amount will be including. I think this is okay. We could say current. Yeah, so once we get to the last digit, and this will be digits. So when we get to the last digit, it'll be the whole number, the whole integer. So first we have a way to represent each of these ranges of numbers. Next we have a prefix that we can add when we're considering 1. And now I think we just need to calculate, just go digit by digit from the most significant digit and say multiply by the subtotal times the digit value. If the digit value is greater than 1, we're going to add another power of 10. based off of the digit position. If we are less than 1, we're not going to add that. Or if we're equal to 1, so if we're equal, greater than, or less than, we have different options. Less than, we don't do anything. Equal, greater than, we add a whole section, power of 10. And if we're less than, then and if we're less than, then we have to add one of these prefix values. And we could just subtract 1 from our digit index if we can, and add the prefix value. If we subtract 1 from our digit number and we go below, then we should just add so actually we could, if we wanted to, if we wanted to get rid of that extra branch, we can just say, we don't have to modify the digit, the index, we can just index right into the prefix and shift the prefixes over 1. So you'd automatically take the correct position. So 0, we get 0. 1, we would get prefix of 1, which is to the right one. So let's shift our values 1 index forwards. Simplify logic later on. So we're going to say 1. Let's equal the digits. And then we have prefix of I minus 1. So 0, yeah, prefix of I. Yeah, that's fine. That's fine. This is actually going to be I minus 1 though. Right, so now, final algorithm. Final algorithm, which is a little bit complicated to explain in words. How are we doing? Yeah, we probably need to have at least 10 minutes left of this. So we're going to say process digit by digit. So we're going to say int I equals 0 from the most significant digit, so digits minus 1. I is greater than or equal to 0. Decrement I. As per below. So we'll say const int d, or short d. Yeah, these don't need to be vowels, these could be shorts. Okay. D is equal to d of I, or digit, or x, we'll call it. Say if x is greater than or equal to 1, do the following. If x is equal to 1, do the following. Plus equals standard power of 10 raised to, now what's this power going to be? Well, the 0th digit is going to be, let's see the first digit, right? So the 0th digit and the 0th index of the digit and the first index of the digit is actually the second digit. And in that case, if you were like 20, for instance, then you would have 10 times you saw a 1. So you have 10 raised to the first. So it is actually raised to I, believe it or not. Yeah. Ret would be plus equals. Now this is the other part that I thought was interesting. So prefix of I, we were saying that before too. So if you were at like 15, for instance, excuse me, then 5 times. Oh no, that's interesting. 5 times you would see 1, and you would have accounted for, so if you saw 15, you would have accounted for 0 through 9, which is 1, and then you'd have you'd have accounted for 0 through 1, which is 1 time, and you would have now the prefix of 5. It's actually 6 times, right? Because you have 1, 0, that happens once, and then, yeah, so if you had something like 1, 9, it would actually be 10 times. So I think it's actually prefix plus 1. Include a single value, a 1 with followed by zeros. Yeah, so increment by 1. For example, 15. Yeah. Rather than 5 ones. So yeah, prefix would only be up to 5. And so if you had like 196, for instance, you'd have 96 numbers from 1 to 96 plus the 100 itself. Yeah, so that's why you have this extra part. And then finally, you plus equals x times subtotal of x. And I think you return red at the end. I think it's that simple. The subtotal of x times x, if we get down to, so let's try executing, see if this compiles first. If we get down to, ooh, runtime error, ouch, out of bounds, oof, okay. X subtotal x, so if you had like 196, right? So you have 1 times, and the digit is 0, 1, 2. Well, that's interesting. I don't know how. Oh, it's not x, it's I. Excuse me. X times subtotal of I. That's my mistake. That would be out of bounds. Is that correct? So the subtotal would be. Let me think here. The subtotal would be. It's the number of digits times whatever that value is. Subtotal of 0. So if we're at index 0, right? Subtotal of 0 should be 0, right? Yeah. If we're at index 1, subtotal should be 1. Yes. If we're at index 2, which we won't be for this number, so how come we got, so here 13 we should get 1 times the subtotal, so 0 through 9 of i's of 1 is 1, so we got 1 times 1 is 1, right? Plus we also set 0 through 9, plus we also get 0 through 3, or yeah, 0 through 3, which is 4. So we should get 4 plus 1. I was only expecting to get 5, but also, why is it 6? Wait, we have 1. Then we have 10. Oh, we also have another 1 for the 11. Oh, I didn't think about that. Oh, that's right. So, yeah, we have 10, 11, 12, 13, 14. So that gives you 5 or 4 more. So there's 1 when you process. That subtotal will give you 1 for 0 through 9. Then you're going to get 1. You're going to get 5 from the prefix. And then finally, when you process the last digit, when it's 0, short as x, if it's greater than or equal to 1, then we would add 1. Right, I should be 0 at that point. Yeah, if it's equal to 1, then you would have prefix of I, which is 0, which should be 0. Which also adds 1, so it's equal to 1, you'd add 1 as well. And then otherwise you're going to add 0 for that subtotal at the end. Yeah, this actually should handle correctly, but for some reason this doesn't give us what we expect. Okay, so I think the algorithm is right. Or no, we'll just do red. Kind of a confusing algorithm, but I think it's right. I may have just calculated some of the values incorrectly. So let's do A and B. I'll just make this C, just so we can at least see what's going on here. We should be pretty much done here, though. Let's see. So A, 10, because we're looking at a 1, greater than or equal to 1. Oh, I'm sorry, it's greater than 1, not it's equal, greater than or equal to. It should be greater than, just be if it's equal, only if it's equal, or only if it's greater. There we go. Okay, that's what we expect. All right. That was a misstep on my part. All right, and let's generate, a whole boatload of cases with our Python script here. We can do 4x, oops. Alrighty, 4 range, let's do 1,000 numbers, and we're going to print, maybe, yeah, 1,000 is fine. Rand range of, could be 0 to 1 billion. And let's actually, oh. Oops. I think actually I may have done something wrong with this program, by the way. Um, 1, 2, 3, 4, 5, 6, 7, 8, 9. I don't know if that's correct. Let's start with that. If that's right, then we'll. Ooh. Uh-oh. Signed integer overflow. Ah, okay. That's close. That's interesting. So we're going to make this a long. See if that helps at all. It's probably this that's not fitting into. I can make these longs, it's fine. That's a subtle thing. Wrong answer. Expected. Ooh. Oh, that's interesting too. So if we see a 1, if we see zeros, the most significant is a 1, say prefix plus 1. Excuse me, well actually, all of these should be wrong then, I think. Yeah, this is what we expect. That would be the subtotal. So I guess only if you're leading. So why do we have this prefix? Well, the problem with the prefix is this should be 0, the prefix. Subtotal, excuse me, what's the subtotal, actually? Let's go to, yeah, so we're wrong for quite a few different numbers, yeah. Let's see. About 100. Expect 21. Huh. Oh, why is that? Let's take a look at 100. Let's do actually 1,000 is a good number to work with. Could kind of figure out what we did wrong in the algorithm. Yeah. This would have been 10 minutes assuming we had the right algorithm, but since it's definitely wrong. So I think the issue is, since x is 0 though, this shouldn't add anything. X is 1, you get prefix plus 1. It's kind of a special case, isn't it? I don't think it's that special. I think I'm just calculating this wrong. Oh, that's interesting. Oh, way off, huh? Yeah, these three numbers will help us to calculate, or these numbers will help us to realize what's wrong. Okay. Okay. So 998, should be 300 and 300, we get 309. So the way we end up processing this, we have 9 times our subtotal, which we said is how many times you get 0 to 99, and we said 0 to 99 is what? See if we got that correct. Alright, if we don't get that correct, then we won't get any of the other things correct. Okay, we got 99 correct. Yeah, that's fine, it's 20. Then we said, so we take 20, multiply that by 10 to give you 300. That's if you're greater than 1. And if you're less than 1, it's not going to be 300. We'll actually only have 1, 0, or 2. So you don't really have a less than 1. Exactly. We'll get into that in a moment. So maybe that's part of the issue. But you do have, if you're greater than 1, then you have that 100 that many times, plus from 1 itself is 100 as well. So here you'd have 100 9 times, so that would be 1800, or 180 rather. So this gives you 180 plus another 100. So this isn't quite right. Yeah, I think I'm calculating this incorrectly. Because you would get that 100, is it 9 times that happens? $0.99 would give you 20. And why is it 20? Because you get 10, you get 10 times, and you get also 0 through 9 happens 10 times, so you get 20. Right, okay. So 0 through 99 happens 9 times, you get 180. Then you also get 100, so 280. But it happens more, but you add another 20. So 998, we said it's at 300. We add another 20 because because you get 280, then you go to 90, and you get 0 through 9 times. Which is right, so that's if you did 900. So if you did 900, that should give you 280 roughly. 289. Okay, that's too many. We have to go over that. Why do we get 289? I think the reason we got 289 is the subtotal is not quite what we were looking for. 0 through 99. Yes. So this is actually, it's not the subtotal that we add here. No. Don't think that's what we add here. I think it's just standard power of 10i times not just the digit, but the I mean, these could be pre-computed, but this is the, if I is 0, oh yeah, I is the, I think it's times I, something like this. What do we get in these cases? If I is 0, I think it's I plus 1, here goes here. Oh, that's very large. It might be I and I minus 1. Something like this. What happens if we do this? I don't know. Oh yeah, there we go. That's more what it's supposed to be. It's a little bit closer, but yeah, maybe the subtotal doesn't need to be this anymore. I mean, we could just exclude this altogether. Just pow times I. So subtotal of 1 would be 10 times 1, or 2, yeah, 2 should be 20. 1 should be 1. So we just say subtotal. I think that's what we want, something like this. Okay, it's better. So we get, 0 to 99 is 20, 1,000 gives you 300, 1,001 gives you 301, 1,002, and 1,001. Okay. 1,002 and 1,001 are not quite right. How about 101, 102, or yeah, 1,001, 1,002 is fine. What we're looking for is, there's not a subtotal, but so yeah, this isn't quite right. This will actually be calculated as we go. This is actually 20, not 21. 300. Yes, I did that wrong. Yeah. Okay. And 1,000 itself, I think we got the right number. We got 301. Yeah. 1, 2, 3, 4, 5, 6. 1, 2. Yeah, I think we got everything right except the last two. So that's interesting. So we got 1,000 now. But now what happens? So we get 1. I think it's 300. And then we get 0, 0, so both of these are just 0 times the subtotal, so these don't add anything. Then we get down to 1, so I is 0, x is 1, x is 1, prefix of I, which is 0. Okay, so why do we add 100? Let's go to 1,001 and 1,002. 1,000. What happened here? Subtotal is 0. Should just be 0. Why are we adding 100 each time? Where did that come from? Is that because it's I, this value? X. What is going on? How is this happening? A, or just X is X. Ret is ret. I is I. And we'll just say branch 1. What happened here? Yeah, okay, we're a little over an hour. Alright, fair enough. Fair enough. I was hoping this wouldn't be so difficult, but it's okay. So we reach branch 1 in every step, which is not correct. Oh. What? What? 3, 2, 1, 0. What? Excuse me. Can we not compare x to a short, to a 1? What is that? What is going on? Compare x greater than 1. What is going on there? Oh, that's bizarre. Oh, I'm sorry. I mislabeled these. I forgot to change the labels. That's my mistake. I was wondering, like, what is... integers not work the way I thought they do now? Okay. So 1. Oh, this is after the subtotal. Yeah, well, this happens every time. Branch 3. Add 300. 0, 300, 0, 301, 0, 301. Now this one. Debug statement at the end just so I can separate each of these. I just would like to do 3 at once here. Okay, so 301 is correct. Now we get 101. Oh. Branch 2. Oh, that's interesting. Excuse me. Because x is 1, and we want to calculate basically 1,000 this one. So x is greater than 1. We want to add this to what we calculated down here. Pretty much you just add 1 to this value down here. No, not quite right. No, yeah. So the problem with this though is I think we should get, so 1,000 should just be that subtotal. Like, I don't know if we even need to add this. If x is greater than 1. Well, first things first, branch 2 is equal to 1. Yeah, so what you want to add is this prefix. But somehow this prefix is 101. Well, that doesn't make a lot of sense. Yeah, you would add 300, that makes sense. And you would add 1. But why is prefix of 1 100? I think we're doing this backwards when I'm creating the prefix. I think we got to go with the most significant digit first. No. Oh, that's interesting. Oh, I see. Okay. I think I did this wrong. Okay, this prefix is wrong. So, you could say this. You could say long power could be start off at 10 raised to the number of digits. You still probably want to do it this way, but what you're going to do is you're going to do a division. So prefix of I is going to be the value itself, n modulo power. That's the way to do it. And we're going to divide equals the power by 10. Yeah, okay, this is interesting. So we use p instead of pow also. I know pow is a function. It gets confusing when you name your variables same names as functions. Yeah. Excuse me. And now one thing also here is if you have a billion, the number of digits is 10. So you would take that modulo, so billion modulo 10 billion is what you need to calculate, right? And that would be a billion. That is correct. And that would be the initial. So we'd actually go from digits to greater than or equal to 1, or greater than or equal to 0. Yeah, greater than or equal to 1, I think. And decrement I. That would give you the right prefixes now. There we go. That's what we're looking for. And we can probably comment these out now. Yeah, I calculated those incorrectly. So I had like roughly the right idea, but it's kind of just small errors here and there. It's kind of hard to formulate all that in your head and get it all right. I want to prefix. Let's just do like 1, 2, 3, 4. One, 2, 3, 4, 2, 3, 4, 3, 4, 4. So yeah, the largest prefix will have all the digits, and then you actually don't need that one. Yeah, I don't think you need that one. But okay, so let's see if this works for a large number of test cases. How do we do? We got 1,000 of them now. Oh, looks correct, and we forgot to remove that one piece of debug code. Nice. Let's go for another 1,000 numbers. I think we got it. Let's reduce the random range to something a little more. Let's go to like 10 to the third or 10 to the fourth. Let's do like 3,000 numbers. I got a lot of numbers. Okay. All right, we're probably correct. If that's correct, that's probably right. Oh, got it. Hey, sweet. Not bad. So, 100%, we use a little bit more memory than everybody else does, because yeah, these could be calculated on the fly, some of these. but I thought it was fine to calculate them ahead of time. So for subtotal, we have this standard power, and yeah, 100% speed. It's pretty quick. Yeah, that was kind of involved, but yeah, counting all the ones, not bad. That's logarithmic in the number of digits, so not constant time. And constant time's kind of hard, and I think not too hard, but you might be able to do it in constant time if you kind of roll up these. I don't know. I think it's a little bit challenging to do it in constant time. That took me a while to kind of piece that together, figure that out, but overall it wasn't too bad. Yeah, an hour and 10 minutes. Okay. What are you gonna do? You know, what can you do? So yeah, thanks again for watching. I'll talk to you soon. Have a good rest of your day. And I don't really have much else to do or say here other than we did it, but it was kind of involved, kind of messy. Some calculating we needed to do and tricky things with indices and whatnot and digits, but we beat 100%, so that's good. And then used a little more memory than you probably needed to, but it's fine. All right, take care. Have a good rest of your day. Talk to you soon. I may or may not solve another problem.